Hi, thank you for showing interest in my Cardiff University Research Opportunity Project. I'm a placement training year student at Cardiff University who did a summer placement on non-additive impact of climate change and abiotic stressors on fish parasite dynamics. Global climate change is the greatest emerging threat to biodiversity in freshwater ecosystems. Parasites with complex life cycles that exist in multiple trophic levels are highly vulnerable to changes in their abiotic environment and thus are ideal indicators of how freshwater ecosystem will respond to multiple stressors. This project tests the individual and combined effects of temperature, dissolved oxygen, and agricultural pesticides on parasite fitness in Belgian and Norwegian lakes to increase our understanding of multiple stressor impact on freshwater ecosystems. For this project, my supervisors were Dr. Rachel Patterson and Professor Jelena Curop. The main parasite we were focused on was Diplostomum pseudospathicium. Fluke eggs are shed with the feces of the birds, and Mericidium then hatch from these eggs. Mericidium penetrates the snail and completes its next developmental stage, turning into Securi. After emerging from the snail, it penetrates its next intermediate host, fish, and enters the lens of the eye, which can lead to the modification of the host behavior and make it more likely to be eaten by the next parasite's host, usually a fish eating bird. Bird that eats the infected fish completes the cycle, allowing the fluke reproduction. The collection of potentially infected snails took place at 9 different sites in Llanpadarn, Snowdonia, Wales. While successful in collection samples from 4 sites, Site 1, Site 2, Site 5 and Site 7, on some occasions the sample size was too small. Here are some snapshots from the snail collection. At the top right picture, you can see how we were separating the snail from the different area from each other. The picture in the middle is a live action shot of supervisors collecting the snails. This table shows the distribution of the snails from the different sites and also gives an overview about the amount of uninfected species of snail radix, infected snails by Diplostomum, and unidentified fork-tailed parasites that infected radix species. Site 5 contained the most fork-tailed parasitic infections, including Diplostomum. It is therefore likely to be the site with the most Diplostomum. I would also like to mention the Site 7, which was a pond isolated from the lake. The amount of the found radix snails was the highest, however, only several snails were infected by simple-tailed parasites, which is not mentioned on the graph. You can see the pictures of the simple-tailed parasites on the right-hand side. This slide shows the general procedure before snail screening. Site 5 was chosen and all the snail from these sites were isolated in plastic containers. The paper on the top of the containers prevented them from escaping. Snails were kept in warmer conditions for a couple hours to stimulate secural shedding. Picture in the middle shows recently shed fork-tailed parasites. Parasite infection was done using the specific literature and comparing differences in basic morphological characteristics of securies. This video represents the working environment of parasite identification. This is one of the snails which was examined and the Diplostomum parasites were found. My last week of Curop had two options: whether to stay in Cardiff and do some statistical analysis summarizing everything we've done in 7 weeks of the project, or to go to Trondheim with Rachel and sample Arctic chars, brown trout and sticklebacks. I decided to go to Trondheim. Our team was small, but it was really friendly and nice. We had two fishermen, Bjorn and Halvard. They woke up every day at 7 a.m. to bring us fish from the net, which were set into different legs. Every day Rachel, Rune, Ramona and I were waking up at 7:30, 8 a.m. and went to the lab by 9 a.m. Our working day didn't have any fixed working time. On average, we spent 9 or 10 hours a day in the lab examining different species of the fish. Ramona Salis and I were volunteers in Norway. By the end of the working day, Caroline was cooking dinner for us in the cabin. These pictures were taken from the two main lakes we were collecting our samples from, Lake Gangusvatnet and Vavatnet, with different latitudes. We were working in a self-set laboratory in the farm which was hosting us, Hafellagard. Rachel, Caroline, and Rune set it up on Monday after they came back from Tromsø. The lab was divided into two sections. The first room had 4 microscopes to analyze the content of the eyes and kidneys of different species of the fish. The second room was equipped for taking pictures of the fish and fish dissection. We made our own teams. Rune and Ramona were working in the cold room and were dissecting fish, taking all the measurements which were important for the analytical data. Rachel and I were spending most of the time in the warm room. Rachel was looking into the fish eyes, meanwhile I was looking into the fish's kidneys. Rachel was examining eyes, as it was mentioned, of different fishes in order to investigate how many of parasites could occupy different layers of the eyes: retina, vitreous humor, and lens. My task was to find all parasites from the kidneys, calculate them, and mix it with an ethanol in the Eppendorf tube. In addition to this, I was taking pictures of the fish prior its dissection. The accommodation was funded. By the end of my Curop, we were interviewed by a district newspaper in Norway. Norwegian people were surprised by the international attention the lake had gotten. Lastly, I would like to thank my supervisors and Cardiff University for giving me the opportunity to participate in this fantastic project. I'm also grateful for the help which was provided by PhD students who were working in the same lab as I did. It was an amazing experience, and if you are thinking about applying for Curop next year, I would strongly recommend you do this.